Well, good morning, good afternoon, good time zone to everybody. Thanks so much for being here today, spending some time with the weather band. We are really grateful to Dr. Amy McGovern for taking some time out of her busy schedule to be here with us. I'm sure for most of you, she needs no introduction, but she is the Lloyd G. and Joyce Austin Presidential Professor at the School of Computer Science and School of Meteorology at the University of Oklahoma. She's also the director of the NSF AI Institute for research on trustworthy AI in weather, climate, and coastal oceanography, as well as being the chief editor of AMS's brand new journal, Artificial Intelligence for the Earth Systems. So Dr. McGovern, thank you so much for being here. We're really excited to hear about your research and what you've been up to.
I guess I need to put that on my list of titles on the title page, but we got our first submission today. I'm super excited. We've been open for submissions for about a week, but you don't open and have people show up right away. We got our first submission today. Super excited. So I was told that this was going to be a more general audience, like potentially general public, and that it should be not super technical. And so I hope that's the case, because as I'm looking through the attendee list, I recognize a bunch of names, and the level of technicality that I put on my slides is not, we'll see how this goes, because what I decided to do was, since you said general public, was to think about, I don't know, I gave a talk at the USS Lexington this summer to the general public as well, trying to talk about basically the same topic. So what AI means and how we can use it for severe weather. And so that was what I was going to do. And good, Tanya, even though I know Tanya says she knows nothing of AI technicality, that's good. I wasn't going to go into too technical details, but I do have two interactive slides, since I was also told this was super interactive and didn't just have to be me talking at you. We did not set this up in advance, so I do not have polls. I just have a blank slide here, and I want to hear in the chat if people can give me some ideas of how they define AI. Like, just since you hear about it in the news too much, I want to get started on thinking about how we can define AI. So I will pause and give you this homework to type in the chat for a minute here. When I do it in person, I have people shout out answers, but. Okay, I see an answer. Social media ads. They are certainly using AI. I would agree with that. Anybody else going to type? It's like in class, I can actually see the people and see whether they're typing. Ooh, somebody wants to be provocative. If else statements. Okay. No, but I know you did that on purpose, given the smiley that's after it. Using computers to help make decisions. Yeah, I like that one. AI, that's a good definition of AI. Technology that can make inferences about the relationship between variables. Yes, certainly. So you can take data in one set and try to figure out how you can relate it to the thing you're trying to predict, for example. And having computers learn things by reviewing lots and lots of data, which I think goes with the previous answer, yes. And that will also get us to the next question of whether or not AI has to involve learning. And there goes the dog again. I told you she was going to bark. Warning, she will bark. It's another point. Just guarantee it. A computer doing what humans do. That's another good one. So trying to solve very hard problems. That's what humans do. And ability to draw patterns from apparently random data. I would say that it is AI and machine learning aren't going to draw patterns from actually random data, but apparently random data because it's so large, certainly. These are all great answers. I love it. And when I do this in person, I tend to type the answers into the slide, but that's a little bit hard when I'm in full screen mode. So you'll just have to go with the fact that your answers are in there. I'm going to bring us to the next one because, oh, and another one just came in. Computers perform tasks that require human intelligence. Yes, so that gets us to actually what I'm putting on the slide. It's like you timed that perfectly. What you see a lot of in the news when they talk about AI, because AI has become sort of a household word in the news these days, it tends to be more machine learning. And so I wanted to see what your definitions were for AI and if they all involve machine learning. And it isn't that it's wrong. It's just I would call it AI as a superset of machine learning. Machine learning is part of what's going on. So AI draws on a whole bunch of other fields, including in my outside of my Venn diagram here, behavioral science, psychology, social science, math, lots and lots of other disciplines. If you do this diagram, you listed every discipline, it would be very, very full. But the definition that I gave for AI in this diagram, and this diagram, by the way, shows up in the EOS paper I had recently, is that computers are solving difficult tasks through experience and observations. And that doesn't use the word adaptation, because I use that word in the definition for machine learning that I give in here. So the machine learning is adapting. You're adapting your models that they improve your performance on your task given some experience. So both AI and machine learning are using experience, using these very large data sets that you talked about in your answers, and trying to find some path to a solution. The difference I would give between AI and machine learning is that machine learning is adaptive. So over time, it can be changing its answers and improving over time. Whereas AI traditionally, without the machine learning part, tends to be more focused on search. A lot of what gets said in the news, though, lately is just AI equals ML. And you can probably, in fact, most of what you see in the news actually is AI equals deep learning, very specifically. And deep learning are the neural networks that are super specialized to work on image data. And then, you know, some other buzzwords you'll see, especially news and Google and all that, data science. I deliberately drew this to be a slightly fuzzy Venn diagram because data science includes techniques that include machine learning and include traditional AI. It's not, you can't subsume any of these inside each other, in my opinion. So data science tends to have a focus on the big data and trying to handle the big data management, the petabyte data sets, the terabyte data sets. And the methods for data science draw on AI and machine learning, and as well as statistics. And I don't want to forget statistics because statistics has been an important foundation for both AI and machine learning. So keeping in mind that I think that we are using AI in many, many ways today that we don't necessarily think about the ways that we are using AI. Like it just happens in the background. It's been put into our everyday devices to the point where you don't necessarily think that you're using the AI. And so you don't even necessarily, I like that the example in here is what's the weather today? You don't necessarily think about how much you could use it for the weather, but we're going to get there in a few slides. I have a bunch of slides about AI first. So intelligent assistants that you use it all the time, you know, your Google Home, now you can get the traffic from your Google Home, but it also reads your calendar. And if you walk by your Google Home, which I don't know if you have one, but I have one that looks an awful lot like that, you can walk by it and it'll actually already bring your schedule up and tell you this is what you need to do. Of course, my commute right now is literally walking from the bedroom to the office, but someday there'll be a commute again that can help you with things like that. And you have in your house likely one of these intelligent assistants because you probably have a smartphone, and then you may or may not have additional things with it. And I don't want to say all the words because then they'll all start activating and talking on here because I have both the Google and the Apple-based one. Other places that you may be seeing your AI in use, and they may be affecting how your everyday life works, but you're not necessarily thinking about it. Google, when you're doing your search for anything you go and type in Google, it's using AI in the background. Amazon, when you go into Amazon and you type in the thing and it figures out exactly what you meant, or let's say it doesn't have what you meant, and it says, did you mean? And it gives you a couple other choices. They typically are pretty good. Or if you figure out, you type in the thing and it says other people bought this, that's not just statistics. They're actually doing AI-based predictions to figure out what do they recommend to you that is most likely to make you click on it and actually go buy it. And those are probably machine learning-based predictions. And then eBay does automated bidding. And there are other like FCC auctions and things like that where they're doing automated bidding. They're using AI as well as game theory in the background to create their automated bidding agents. And it's a place that I think a lot of people don't necessarily think about the AI affecting their lives, but it does. And then Tanya gave a definition in the beginning involving social media, and AI most certainly is involved in our social media. You know, Facebook, Instagram, and Twitter are the ones I grabbed the logos up here, all the other social media sites. There's bots out there. There's things that are trying to retweet and not look like a bot, but they're really a bot that are trying to affect how you're viewing the world. There's a lot of misinformation agents out there. And then there's AI that's trying to counteract all that misinformation as well. It's a challenging task. That is, if you've ever wondered why they haven't gotten it right yet and they haven't solved it, it's because it's really, really, really hard. I wanted to grab another set of, I have 2 interactive slides. This is my second interactive slide. What ways, now that you've had all these examples of AI, what ways can you think of that you're using AI that maybe you weren't thinking of before already in your life? And feel free to put them in the chat again. And I'll start reading them off so everybody can see them. And by the way, these can include good and bad examples of AI in your lives. One of the other interactive questions that I often ask when I do this talk involves the ways in which AI could make your life both better and worse. But let's start with just examples. Friend suggestions on social media, yes. Suggestions on Netflix, yes. Those are both good examples. And sometimes the friend suggestions are kind of creepy because sometimes it's somebody that you know, but you don't really want to talk to. Adjusting driving directions based on traffic flow. Yes, that's a good one. And have you noticed that Google lately has adjusted its driving predictions based on how you drive? So it now no longer assumes that you drive like over or under the speed limit. It actually adjusts your predictions of arrival time based on how you typically drive. Ads that show up when I read the Washington Post. Yes, so those are based on something called cookies, which get dropped into your computer, and then it can track everything you do. And then it says, oh, people who visited they've read this article in the Washington Post, now they want to get an ad for this thing. I actually find that kind of scary sometimes, but sometimes it's useful. Voice recognition, most definitely. I was waiting for somebody to say that one. That one's one that I think people don't think about enough. That is an AI technique that is perfected itself pretty well, at least for the American accent. There's a whole discussion here on inclusivity. They're not as good at the other accents, but voice recognition has come a really, really long way. Recommended content to watch on YouTube, TikTok, etc. Yes, so these are all great. I am glad you are now thinking about AI in your everyday lives. And let me throw some, and I don't know why the animations, I'm just gonna throw them all out there and then we'll talk about them. Hold on. Like why half the animations showed up. If you look at AI in Hollywood tends to have sort of two sides to it. It's either really, really scary, which is what most of these are, or it can be good, right? So I use this slide in class, and it's fun because it's mostly 18 to 20-year-olds, and most of these movies are old, and so they have no idea what the movies are. I'm assuming this audience can do a little bit better on figuring out what these movies are, but the AI in most of these is kind of scary. It's gone bad, and it's trying to take over the world. It's trying to have play a game and kill everybody, or the one that I have in French there, I really need to find the Short Circuit non in French, but that's the movie poster I could find on Google. That one doesn't tend to be scary. He just becomes alive because he gets hit by a strike of lightning. And I don't think Data is considered to be a bad AI example in the news, but most of the rest of these are kind of questioning our humanity and figuring out what's wrong. And I see there are a couple other answers of other ways we're using AI in everyday life. And I agree with both of those: Google photo recognition, facial recognition, and level 1 desk help chat. Oh my gosh, please save me from those. They drive me crazy. But yes, I agree. AI, one of the ways in which you've seen AI in your everyday life, and nobody gave me this one because I guess nobody's a gamer, is that you say AI in games. And AI has been used in games for a very long time. It beat Deep Blue. And then more modern games, we have the Jeopardy winning player that did really, really well, Watson, and we have AlphaGo and AlphaStar, both of which are examples from more recent and much more complicated games. And both of those, not Watson, but the AlphaGo and AlphaStar, both use deep learning, and they are really, really good. So we'll talk more about the weather forecasting, but I wanted to start because I was told this was a nice general audience. I wanted to start with sort of the ways in which to get you thinking about the ways in which AI is being used in your everyday lives, because one of the things I want to talk about at the end also is all the ways in which we need to make sure that we're doing AI correctly, in addition to talking about the ways we're making trustworthy AI. So AI also is used for a whole bunch of medical examples, identifying cancer in your images, disease diagnosis, robotic surgery. The picture that's given here is actually a relatively old picture because the robots have gotten much, much better. It's used to do just things inside your computer. I noticed that nobody gave me an example of this, probably because you don't think about what's going on inside your computer, which I totally get. My degree is in computer science, so sometimes I have forced to think too hard about what's going on inside my computer. Like when you write your code, or when you just run a program, just run Word, just run PowerPoint, it's running all these instructions in the background, and you don't have to think about that. That's good. But when it's running them, you want them to run very quickly and very efficiently, and you don't want to have to double click on your application and wait 5 minutes for it to start. All of that behind the scenes is trying to guess what's going on, what it is you're going to click on, and is trying to use AI to do that and to make things happen very quickly. We talked a little bit about sales, and definitely we're talking about ads. AI is most definitely used in the marketing to subsets and tracking what you're doing. And then my final one that I like to talk about just as fun. The lower right-hand picture here, I don't know if you can see my mouse if I put the mouse over there, but my lower right-hand picture down here is an example of an AI-based art exhibit where, and this was actually created by my husband and another faculty member who used to be here at OU in art, and they jointly worked together to make this interactive art exhibit where you could walk into the exhibit. These are called bions, and they are each one of them is a little embedded processor, and they would sing to you, and you'd walk into them and you would interact with them, and they would change their behavior based on how you were interacting with them. And it was really, really cool because I haven't seen a whole lot of examples of interactive art, but it was using AI to try to mimic some systems that are going on in the real world. And then my final example, I like to grab because I like to talk about, I have people showing up outside my office. I like to talk about space. AI is used for space robotics. That's another one. We could talk about space weather, but when we talk about space weather, at least within AMS, we tend to talk about forecasting things that are going on in the sun. We could also talk about the weather on Mars, and that could be another fun application, talking about forecasting the dust storms. And then there's all these applications to the robots that are currently on Mars. So can the helicopter fly? How do we know the weather is good enough for the helicopter to fly on Mars? Can it drill? Can it identify the different pieces of rocks? Can it figure out which rocks it should go to so that it should do its samples there, and what's novel and what it has already seen, and it shouldn't just bother with that because it has a limited amount of time and a limited lifespan. So that was my introduction to sort of general AI, but I want to move to AI and weather forecasting. And I think some of this is preaching to this choir, but not all of it, because I don't know the whole audience, and I know that some of you are not necessarily meteorologists. So we know that our climate is changing. I grabbed this picture from the floods that happened in Germany this summer, where there were just massive floods. This is the back half of a house that was mostly washed away. We also had massive heat waves this summer. We had same article, grabbing pictures of the fires that were coming through. Our climate is changing. Our climate change is affecting our weather extremes, and we really need to do better at being able to understand this and to improve our resiliency. And so this is a picture from a tornado that happened in the Southeast from one of our AI2ES members, a picture of some hail. Hurricanes from a couple of years ago. I don't remember which three there are, but I'm sure the meteorologists remember which three those are. It's a couple-year-old picture. Some sea turtles, those are affected by this climate changing. As the sea is warming, their habitats are moving. And as things like the February cold spell happen, they get really cold, they get cold stunned, they rise up to the surface and they die. And this past February was the largest cold stunning event that has ever happened. And we're using AI to try to help improve the predictions of those events so we can save more of the turtles. They had over 10,000 turtles cold stunned. And then the final picture up here is a picture of some probes that are being deployed by one of our collaborators to study the ocean. So all of these pictures, including the previous two, are showing things that are happening in our weather and our climate. And we're not going to be able to use AI to stop any of these things. We could have that discussion afterwards if you really want to talk about climate modification, but I don't, that's not a path I'm going down at all. I don't want to look at that. I want to look at, can we improve the prediction and can we improve the understanding? Because if we can improve the prediction and the understanding, then we can improve our resiliency to all of these events. So that, for example, the picture of the hail, that's my hand holding the hail at my house. I should have grabbed, but I don't have pictures of it. The hail that destroyed my roof for the fourth time. I'm on my fourth roof in 17 years here. That particular storm, you could see it about 30 minutes out. If there hadn't been a lot of warning for it that people were paying attention to, it was warned, but they were not paying attention to it because there happened to be a presidential talk that was Biden's 100 days going on at the time. And so people weren't watching that, they were watching the news. And we couldn't, again, have used the AI to stop the hailstorm. But if we had somehow realized that we needed to really warn people and tell people that their cars were about to be destroyed throughout the entire town of Norman, and given them, hey, 15 minutes, go quick, clean out your garage and get your cars inside. You'll still need a new roof, but at least you won't need new cars. That would have saved a lot of damage. If you could have given them an hour notice at the car dealers, hey, every single car on your lot is about to be destroyed, it would have saved a lot of damage. So looking at this, and I was talking about trying to improve our climate resiliency. We had an awful lot of billion-dollar weather disasters last year. This year's shaping up to look an awful lot the same. Again, the AI is not going to stop these weather disasters, but we could perhaps make these weather disasters not billion-dollar disasters if we use the AI correctly. If we had improved the hail prediction in the example that I just gave, that particular day, which is the Texas and Oklahoma severe weather storms, the April 27th to 28th, destroyed cars basically throughout Oklahoma and Texas because there were multiple hailstorms, all with 3-inch hail and 80-mile-an-hour winds. It was fabulous, speaking as somebody who was inside a house that was getting destroyed by it. It was kind of terrifying, actually. And if we had been able to give enough warning and enough precise warning in advance, we could have at least saved a lot of the cars. Again, we wouldn't have saved the roofs. You can't move your house, but you could have saved RVs, you could have saved cars, you could have saved windows. A lot of people lost windows on that storm, and that's something that doesn't typically happen here. We get roofs hit, but typically we don't lose windows. And that could have made it go from $1 billion disaster to a less than $1 billion disaster. And finally, while we're talking about sort of why we want to use AI for severe weather and what we can do with it, our sensing systems are getting more and more sensing systems online. We're getting higher and higher resolution data, and it's getting to the point where the humans really can't deal with it. So I grabbed some examples. Weather observations really are the original big data set. This is just a NextRad mosaic I grabbed from May 16 to May 17, 2021, just showing how much data there is out there. And if you're trying to learn to do predictions, and yes, I grabbed a severe day that had lots of storms, but if you're trying to learn to do very precise predictions, this is an awful lot of data, which gets us to our definitions we had in the beginning. And then here's the satellite data that's coming in for the exact same storm system in the exact same time. The humans, that's just, eventually this is data overload. And if you want to think about our model data is also big data. I mean, it is generally data overload. I grabbed this GFS data from a website online, but I think that the AMS group is familiar with how much data the models generate. All of this is to say that our forecasters are trying to make critical life or death decisions. Our end users are making critical protective decisions, and the end user needs differ quite greatly. If you're a forecaster and you're trying to issue a tornado warning, that's one decision. If you're a member of the general public and you're trying to decide, do I evacuate for a hurricane or not? Or do I go get my kids early from school? Or do I close up my business early and send my employees home? These are all different levels of decisions that need to be made. And whatever we're generating for our trustworthy AI and our AI predictions needs to take into account the needs of the end users. So what I was going to talk about, and I'm happy, by the way, I'm happy throughout to answer questions. I should have said that. I didn't plan for super technical detail on this, but we're going to have a couple of slides talking about what it is we're doing. And if you want to ask questions about specific details, I am happy to do it. I think my picture is probably sitting on top of some of these logos. Problem with Zoom. So I am the director for this new NSF AI Institute. It is the short name of our institute is AI2ES. And all of the partners that are on here, we have been adding partners over this last year. We've been in existence for about a year. So we have all of these academic partners. OU is the lead institution, Texas A&M, Corpus Christi, North Carolina State, Colorado State, University of Albany, Central Michigan, University of Washington, and Del Mar College. They're a community college partner, and I will talk about them in a couple of slides. We're partnered with NOAA, partnered with NCAR, and then all of the private industry partners that are listed over there. And together we are working to create a unique institute that is cross-sector, cross-institution, that is working to benefit humanity by developing novel, physically based, and what I mean by that is that they're going to be based on the laws of physics, AI techniques that are demonstrated to be trustworthy. They directly impact the prediction and the understanding and the communication of the high impact environmental hazards that we were talking about. Now, if I make my slides go forward, here we go. So the 4 focuses that we have the first 3 focuses, focus 1, 2, and 3, all work together. We have foundational research in trustworthy AI and machine learning, use-inspired research in environmental science, and foundational research in risk communication. And so we should talk about what all those mean, because as I said, I don't know the full audience here and how versed you are in each one of those things. And then the final focus is improving our broadening participation in workforce development. Those go hand in hand. We really want to improve the diversity of the AI and environmental science, meteorological, atmospheric, oceanic workforce. So let's jump in. I only, in the nature of being told I had 30 minutes and then supposed to be lots of Q&A, only have a very short set of slides on these, but I am happy to answer questions. The 3 things we're trying to do for the foundational AI, and I will answer that one. That's an excellent question. I'm going to answer that in a few slides if we don't mind. I want to talk about ethics and responsible AI, and I would consider that as part of it. But maybe I answer it now. Hold on, and I'll get there. Develop explainable AI. So this will be explainable and interpretable AI. AI that you can see inside the model and you can understand what it is that the model is doing, and do this in a way that it is consistent with the priorities of the atmospheric scientists and the ocean scientists and the climate scientists that we're working with. Develop physics-based AI, that's missing a D, physics-based AI so that it is respecting the laws of physics, and then develop robust AI such that the AI learns under a variety of conditions, including adversarial conditions, such as presented on the bottom here, where I have a picture of the El Reno mesonet station right after it got hit by a tornado. So it recorded a gust of 151 mile an hour wind. If you were learning on this data, if you were using it as machine learning, you might look at it and say, that's a statistical anomaly and throw it out. But the truth is it really got hit by a tornado. And then it destroyed the station. So it recorded this burst of tornadic wind, and then it was destroyed, meaning that it gave you no more valid readings. And you need your AI to be robust to both the fact that this 150 mile an hour wind gust was real, to handle it if it wasn't real, if it was just some anomalous reading, and to handle the fact that the station readings went down after that. So along those lines, I'll answer that question now rather than waiting. Since correlation does not prove causation, how can AI algorithms be designed to guard against associations that are not valid? That is a really, really good question. And I think the reason I want to answer that now is that part of what we're trying to do is with the first two parts, well, I would say that fits into all three of these. By developing explainable and interpretable AI, you can see inside the model, so you can figure out what it is that the model has learned, and you can figure out whether or not the model has learned something that is wrong. And part of that is that you're going to use your physics-based knowledge to say, time does not flow backwards, for example. So this cannot possibly be that this is causing this. I might give an example, that correlation and causation, in that one of the first AI models I worked on trying to look at tornado modeling, this was years ago, this was like 15 years ago, was identifying that there's that every time there was hail, there was a tornado. Well, we know that tornadic storms do tend to be more severe and do tend to have hail with them, but it was trying to imply that if there was hail, there was a tornado, which is an incorrect assumption, right? And the way that we figured out that it was doing something like that was wrong was by developing these models where we could look inside it and say, what in the world have you learned? Oh, you learned that if there's hail, there's a tornado. Well, that's probably not the best answer. It's not wrong in the sense that there are hail and severe storms, but it wasn't right either in the sense that it didn't help us. So my answer to your question is that you need to focus on doing all three of these: developing the explainable and interpretable AI, making sure that it's respecting the laws of physics, and making sure that it's robust so that it is robust in the cases of the data going wrong, and you can help guard against these correlation and causation questions. I hope that answers the question. If not, type more in the chat. So the second, I said there were four focuses. There are three focuses that work together in a cycle, and then the fourth focus that I'm going to talk about. We have 5 research areas that we're working on. We're looking at convective weather, so looking at hail, wind, lightning, tornadoes, and particularly looking, this graphic is from, the left-hand graphic here is from predicting hail in the 24 hours in advance. So trying to actually predict where it's going to hail 24 hours in advance just based on the model guidance. And then we have the pictures of the probability swaths by the machine learning model, and then the actual hail that happened, because we're looking at verification of this. And you can see that it did really, really well. We have recently begun working on doing nowcasting of hail using both the observations and the model guidance, trying to do 0 to 3 hour nowcasting. And we were actually looking at the April 28th storm that I talked about, because that was one of the storms that if we could have given an hour's notice, you could have saved a lot of property. The second example of what we're working on inside AHBS is winter weather. And here we're looking at, for example, trying to predict icing and snowfall and visibility. So the New York State Mesonet has a bunch of cameras that are available that are taking images every 5 minutes and trying to understand what the visibility is and what that means for the drivers. And then trying to predict snowfall and icing, because the less ice that you use, the better it is for the environment. But of course, if you use no ice, it might be better for the environment, but it's worse for the people because then they have accidents. So trying to figure out how to juggle the trade-off there of trying to get the prediction to be very precise so that we can just put the correct amount of ice on and not affect the environment too adversely. And one thing before I go to the next one I want to say is that the end users that are available for both of these are completely different, right? The end users for the convective weather products are probably, we're more looking at the forecasters and emerging managers. The winter weather, we're actually working with the State Department, end users, the New York State Department of Transportation, for example. I see a question coming in. Hold on. How is current state research impacting physical risk models for multiple natural hazards and the reinsurance industry? Oh, that's a good one. We actually just started, we have a proposal for a project for next summer, a summer student project. It's not a huge project, to look at what models are in use by the insurance industry and the lawyers who work for the insurance industry to do their validation of their data. And it's an interesting question. Most of them don't talk about what they do. So I don't actually have a good answer to how it's impacting the reinsurance industry yet, because that industry doesn't like to talk about what they do. They like to keep it proprietary. If the first half of your question of just how's it impacting the risk models in general, yeah, I don't, again, I don't know that that industry talks a whole lot. If I'm wrong, I'd be glad to hear it. Were operational models used to produce these results? Operational versus research-based. Excellent question. For the hail prediction, we have been working inside one of NOAA's hazardous weather testbed, which is a way to test a model before it is made operational. Actually going from research to operations is a very long process, multiple years. And we have been testing our hail model in there for a couple of years. And I think I mean, we have funding from NOAA to transition it over. It is not yet operational because that once you hand them the code, then they have to do their half. The winter weather, I believe they are actually using these operationally with the New York State Department of Transportation. And some of these other ones that I will talk about, I will mention again which ones are operational and which ones aren't yet. Well, some of them are just research-based. So the one that I'm about to say for the satellite-based observations, this one is, the satellites are operational, but the AI that we're talking about is still in the research phase. So an example project inside here for the tropical cyclones or the hurricanes is that we're looking at the two different sets of satellites that orbit all the time. There's the polar orbiting satellites and the geostationary satellites. The geostationary satellites give you data much more frequently, every 10 to 15 minutes, but they don't have any microwave available, so they can't see inside the storm. The polar orbiting satellites have microwave imagery, but they're only available once or twice a day. And so what we're doing is we're training an AI method to predict, given the geostationary satellite data, what the microwave data should look like. And then using the XAI, the explainable AI and the interpretable AI and the physics-based AI to make sure what it's learned is physically plausible. And then we can deploy that on the geostationary satellites to actually generate simulated microwave imagery that then can be used to improve our understanding of how the storm is evolving. That one is not yet operational. That one is still very much in research mode. Some of the other models, so looking at coastal oceanography, I know that one of these is operational. So the upper right one, when we talked about the turtles in the very beginning, the model that predicts the temperature of the Corpus Christi Bay, the Laguna Madre specifically, is operational and is using AI. It is a relatively simple model. It's just a neural network. It's not a deep learning model. It's not any of the fancy dancy, shiny new hammers that you read about in the news. It works really well what it's trying to do. It's just trying to predict the temperature. And that was done in collaboration with IBM as well as Texas A&M Corpus Christi. They are working on testing their model for predicting fog. My understanding is it is not yet operational, but is getting closer. And then on the other side, we have other oceanography applications, including looking at harmful algal blooms and studying ocean eddies, which are very large scale circulations in the Gulf of Mexico that can last for months. And they affect the oil rigs as well as the weather in the Gulf of Mexico. And so we want to be able to predict both the formation and the dissipation of those. Do the NWS threats in motion severe weather warnings use AI? I don't know the answer to that. I know the facet system is using machine learning. I don't know the answer to the threats in motion warning system. I'm sorry. I would be glad to figure it out. It's not a group that I have been working with, so I don't know the answer. Keep throwing the questions in the chat though, this is great. The third half, I said there were three focuses that are working together. There's the development of the foundational AI, there's the use cases. The third half that really is the key that puts the three of them together is that we're actually working with risk communication researchers to figure out whether or not the AI we've developed is actually trustworthy, in what situations it's trustworthy, in what situations the end users would actually use the AI versus what situations the end users might just say, nope, chuck that AI out the door. I'm not interested and I have too much else going on. So our use cases that we're looking at include all 5 of those things that we talked about. We're looking at mostly expert decision makers through some collaborations with our private industry partners. We may be looking at some of the general public, but right now we're mostly looking at government end user, government decision makers with a little bit of industry. Some examples of who we're working with are on here, primarily right now the National Weather Service, but we are working with others, Department of Transportation, for example, and doing a mixture of interviews and experiments, as well as surveys, whether in their natural settings. And so these surveys just started. We've been in existence for a year as an institute, and that first year we did pre-tests and developing the surveys, and now they are just doing the surveys and a lot of these beginning interviews. And I don't have a full set of results. What I have is a example from one of the pre-tests, but we co-developed a semi-structured interview. We have, this just says about to begin, but we have begun the data collection. We're measuring their challenges, their needs, their perceptions and attitudes of AI, and why they might trust or not trust something. And so, for example, there's a result from one of the pre-tests where we say, what does the term trustworthiness mean to you? And the first word that comes to mind is reliability. When you say trustworthiness, I guess I'm thinking in my head like a verification sense. Is this reliable in this situation? Is it reliable in this part of my domain? Because there's all these inherent limitations to anything, right? So when you say trustworthiness, it can be demonstrated that it's reliable for me in my situation. And I think that's a great answer. You know, that it's part of what we need to understand with the AI, that a lot of people outside of a domain, particularly the AI scientists, who sort of come in and think, I can develop this AI, it's going to solve everything, don't understand that you can't just take the AI and throw it over the fence, and it's not going to work in all these situations. There is no weather model that is out there that works in every situation. When I was giving a talk last week, somebody gave me the quote of all models are wrong, it's just some of them are usefully wrong. We need to understand that that's going to be the case for AI. It's not always going to be right. And we need to know when it's reliable, and we need to know when it's not reliable so that we can trust it. And also it would be really cool if the AI itself could say, I don't believe I'm reliable in this prediction, so I need to say, you should not count on me here. And then it would be interesting to say, what does that do to the human trust? If the AI actually says, don't trust me right here, but trust me over here. It's a really interesting set of questions. I don't have all the answers to it. Okay, the fourth focus for our institute is education and workforce development. And I didn't put it at the end because it's last. It is highly important in my opinion. We really need to improve the broadening of our workforce across all levels. So we are working K through 20 as well as workforce retraining. One of the things that I like to highlight is we have one of the first community college AI curriculum. It started in this fall. It's a 14-hour certificate award. I got to get the right words here. Occupational skills award is what it is. And then from the students who take this and get these 14 hours can either continue on at Del Mar, they can transfer these units over to Texas A&M Corpus Christi, or they can go straight out and get a job with it because they now have an award. And we're prototyping this at a Hispanic serving, minority serving institution because we really want to make sure that we are developing something that improves the diversity and works for that population before we take it nationwide. So this is just an example of some of what we're doing. We're also doing summer schools. We have just like last week, starting the planning for our summer school for next summer. There'll be dates and more information coming out. I don't want to end without saying this part too, because this is actually where one of those questions got me in the beginning as well. We are the NSF AI Institute for Research on Trustworthy AI and Weather, Climate, and Coastal Oceanography. And that word trustworthy is really, really important. And as we started to get into this in the last year, we realized that no one is really talking about the ethical and responsible use of AI for this community. The ethical and responsible use of AI is starting to come out into the news. You're starting to see examples in the news of the ways in which AI can be misused. But nobody's talking about it for the weather community and the climate community. And so we're trying to talk about it. So I have a whole talk I can give on this. I'm not doing that because we have just a few, I was told to be interactive and to end on time. So I'm going to do that. Just a couple slides to show you ways in which AI, we need to pay attention to it, because one of the things that happens when I first start talking about ethical and responsible use of AI for the environmental science community is lots of people said to me, well, why do I need to do that? Weather's not biased. There is no bias in weather data. There's no bias in what's going on. The weather affects everyone. Wrong. The weather does not affect everyone equally. And so what we are working on, we're working on developing principles for ethical and responsible use of AI for weather and climate applications. We're developing approaches to identify bias in our weather and our climate data. And then we want to identify links between the ethical and responsible principles and the trust in the AI and weather and climate. And I grabbed this fun cartoon because we're trying to develop something that looks an awful lot like the top one, where Asimov says, here's an ordering of the 3 laws of robotics. We'd like to say, here are your principles for ethical and responsible use of AI. And they need to be in the correct order. If you get them in the correct order, you get a nice balanced world. That's what you see from Asimov's stories. Things do not typically go wrong. If you get them in the wrong order, which is of course how he writes the stories, somebody did something slightly different to the laws, you end up in these other worlds where it's either frustrating or a killbot hellscape. And we don't want to do that with our AI that we're developing for weather and climate. So as we move to the question of could there be biases in weather and climate? And I have probably 15 examples. I brought it down to one slide so that I could show you. But if you want to hear more of the examples, ask me in the questions. Here are 2 examples in which the data in weather, specifically, not climate, could be biased. So the one on the farthest right is an example of hail reports, all the hail reports from 1955 to 2014. And if you look at that carefully, you might note it's plotted on top of a road map. It seems to only hail where there's people. Do you think that this is actually how it looks? I would assume not. Hail falls pretty uniformly. The problem is this is where the hail reports are. If you were to train your AI data on this, you could unintentionally replicate some biases such that you might say, well, it's not going to hail at your house because you're rural, but it's going to hail over here in the city because that's where lots of the reports are, or it's only going to hail along the roads. Yes, those sound silly, but if you didn't examine your data beforehand, you might train your model to do that. And then you say, okay, I'm going to understand there's population biases to my data, but there's no other biases to my data. Well, welcome to humanity. Humans also report data wrong. So here's an example on the left-hand side here, in the middle actually, from the MPING system, which is the Meteorological Phenomena Identification Near the Ground, where humans, it's just a crowdsourced system. It's a free app. You can download it and you can report your tornado, your wind, your hail, how strong you think it was, how big the hail was, et cetera. And this is a huge data set because it's reported by people all over. It has fewer of the population biases because you can get it anywhere. You can use it on your phone. But then there are people who go out there and play with it and try to do things like create intentional biases. So this was a day where somebody hacked the API and just started tracing out the state of Alabama. They did other things. It's not funny. And this data, if you were using it for machine learning, would be very, very biased. And if you think, oh, well, that's just a one-off. Well, think about insurance fraud and think about the ways in which you might be using this data that was reported, but that somebody reported it because they wanted to be able to get a new roof. Oh, it hailed at my house too, even though it only really hailed at your neighbor's house because they want to be able to get the new roof. If we're trying to draw, very precise boundaries, this could affect the data. So humans are humans, and any data that's going to rely on the humans could have issues, intentional or unintentional. And we need to make sure that when we look at data and we're learning for weather and climate data, that we are not accidentally learning something very wrong because of this. And I have one final slide. My final slide is just that AI can really help us to be resilient to climate change. And climate change and environmental science are wicked problems. The issues are deep, they're complex. We have 5 years of funding for this. I have a vision of making a multi-agency, multi-sector center that is much larger and longer scale and includes international partnerships that will help address these problems at a broader scale. And that is it. And my thanks to NSF for our funding. I will take more questions. I see one in the chat that says that it is a thank you. But I will wait for questions. Thank you, Tanya. Can I give out my contact information? Yes. It was on slide 1. Okay, that was a way to go all the way back. I probably could have done that more efficiently. Sorry. There you go. Next time I'll do that a little bit more efficiently. But yes, there's the contact information. Feel free to email me. And also the AI2ES has a website, which I will type into the chat. We have a lot of information, and we will have our summer school announced up there. We did a summer school last summer. It is going to be online again. We're currently having a discussion of doing a hybrid approach where there'll be a couple of sites that will host something in person, but it won't be just in person only. There'll be sites that'll have, small locations as well as the hybrid online approach. And there'll be a combination between the summer school that we've done and a hackathon as well. And there'll be 2 levels of hackathon There's gonna be sort of a novice hackathon and a more advanced users hackathon. We just started the planning last week. We're having a lot of fun with it though. Other questions? If not, I can see that our host has reappeared. I don't know. Does the AI deal with the geostationary sensors and polar hour? Yes. Yes, that's certainly something that has to do. The deep learning has to deal with the different resolutions between the two sensing systems, the spatial resolutions as well as the temporal. Are there ways to be involved in your group? Send me an email. We'll talk more, because it's hard to answer that when this is a one-way communication, since you can only type. Send me an email and we can have a chat. What do I see is the biggest challenge for achieving my goals in AI and forecasting? Oh, that is an excellent one. I don't think it's the technical challenge, quite frankly. I think the AI is ready. I think that getting it moved all the way to operations is a huge challenge, and getting the data available for everybody is a huge challenge. A lot of the data is not yet sort of ready in an easy way, in the sense that getting an operational feed is hard right now for many data sets. I think the biggest challenges are going to be policy at the moment. Just trying to get us to, and as well as people, we want to be able to actually take the AI and actually use it. So understanding what it means to be trustworthy, and understanding the ways in which we can use it, and then helping people to learn to adapt to use the new systems are all big challenges. I think there's a lot of technical AI to be solved, but I think it's all solvable. These are all great questions.
I'd love to ask a question about the
Sure.
the data sources that you were, because that reminder from the hail reporting was really fantastic to think about, kind of skewing the results and impacting AI. So do you have like a best case scenario data reporting? Like what could those networks do, like CocoRa's or MPing, to actually provide the best possible data?
That's an excellent question. I think if we could get a really good sampling, then we could use those networks to perhaps combine with the observations, which are, so things like mesh, which is a maximum expected size of hail, that's a radar-based product. We use that as well, but mesh tends to be over predictive. If we could use CocoRa's and MPing and the storm reports database to actually correct and create sort of an unbiased approach that would be covering everything everywhere, then that would be my dream of the kind of data that we could have. It doesn't exist yet, but it's getting there. I mean, for hail, it's a little bit easier than some of the other data sources. Things like, there are a lot of places in the world that don't have great radar coverage right now.
Yeah, it's been fascinating. We've had a couple different folks talking about the availability of data and just the different problems that causes. So it's interesting to see how different disciplines approach that.
We really need, and I think NOAA is finally starting to understand that we really need some sort of central repository for all the data. So all the data can be found, and all the data can be labeled, and there can be metadata for it in a consistent way. And so that people would know, okay, these storm reports are going to be biased because they're generated by humans, but here it is, I can download it, right? And then I can mix it with this other reports database or things like that. We need something like that. Nothing like that in a centralized form exists right now. And I think that, there was a question asked in the chat about big challenges. That's a huge challenge. I see it as a policy challenge, but it needs to happen. We need a centralized AI-ready data set. And it needs to be operationally, there needs to be an operational feed in it. It can't be that you're only getting data that's 5 years old.
Well, I look forward to all the CocoRa's and all the weather band members uniting to get better data out there.
I hope so too. All right, I guess there's no other questions, but there is one more that just came in. Do we need to know the exact predictors to train the AI models, or the AI models? You mean like, can they learn without labels? Is that what you mean? Or I think I need some more specifics to answer that. Oh, so learn without labels. There are unsupervised methods out there. They have self-organizing maps is one that gets used in meteorology that gets talked about at AMS. They're generally used just to sort of identify regimes and patterns. They aren't generally used to do prediction forecasting. They aren't really ready for that yet. By the way, there's one in the Q&A too, which I didn't, it just showed up, so I don't know. I'm gonna put that over here too. I will answer the chat and then I'll go. The Q&A I think has been waiting. Has MPing implemented QA to eliminate multiple entries that in succession will be impossible for normal transportation? Yes, MPing has fixed the bugs and that includes QA. Okay. Am I relying on human subjective analysis for, I mean, that doesn't, by the way, mean that people can't hack into new systems. People can always find new bugs. They fixed a bug that it did exist. Am I relying on human subjective analysis for verification on whether the AI models are improving the forecast over existing physics models? Oh, no, we're doing lots of objective analysis, lots and lots of comparisons on cases and lots of data where you're doing objective analysis. For the example, the hail data, you know, is it reliable? What's the AUC, the area under the ROC curve, all the different skill metrics. We also do the human subjective analysis because in the end, it's humans who issue the forecast. So in the end, it's humans who are going to use the AI models, but we need to make sure that objectively they are skillful as well. Have you tried to use AI to automatically construct communications to different customer groups? That's an excellent question, not yet. And we're not doing any natural language processing right now, but that is certainly something that I could see happening. And I think that's probably more a good question for some of our private industry partners. For example, IBM and Google have a large reach through their phone apps, and they could do the communications that way. Is there a resource where we can see updates on the research? Yes, we're actually about to put a website update up because what's up there is about a year old. I'm about to put a major update up on all of the different projects that are happening. It should go up in the next week or two. So the website again, and I'll type it into the chat too. And I try to tweet when the website update happens, I will tweet about it as well. And it is AI2. I'm doing this from my head. I think that's the Twitter handle. No, I'm missing something. AI2. I just spelled that wrong. There. I tried to get AI2ES, but somebody else took it and they weren't giving it up. But we will have lots of updates there. So follow us on Twitter and check on the website.
That's fantastic stuff. Thank you so much for going through all of this and making it understandable. We will make this available to Weatherband members and friends at amsweatherband.org. So head on over there to continue the conversation and check out the replay of this. Thank you again, Dr. McGovern. We really appreciate it.
Thank you. Sure. Bye.
Bye, everyone. Have a great rest of your day.